All right, here's the lesson on polynomials. First, we need to know what is a polynomial. And the best way to understand it is by looking at all the exponents in the equation and seeing if all the exponents are positive whole numbers. If every exponent is a positive whole exponent, then it's a polynomial. The shape and continuity, the graph of a polynomial is smooth and continuous. No breaks, no holes, no asymptotes, no sharp corners. Degree, this is a unique word for polynomials. Degree can mean a bunch of different things. But in this case, degree means the greatest exponent. And the degree tells you what type of polynomial it is. So when you look at the greatest exponent, it tells you. So if I look here, what you don't see is x to the exponent 0. So the greatest, when you only see a number and no letter, the greatest exponent is 0, and we call that a constant. And if you graphed it, that would be a horizontal line. Here, the exponent is invisible. That's 1, and that's a slanted line, linear. Here, the greatest exponent is 2. We call that a quadratic. The graph's a parabola. Here, the greatest exponent is 3. That's called a cubic. These top 4 are common, and you need to know their names. The next 2 are not common, they're rare, and you don't need to know their names. So the greatest exponent is 4, we call that a quartic. If the greatest exponent is 5, we call that a quintic. Ultimately, if it's greater than 3, anything greater is just going to be called a higher order polynomial. And so we'll just call it a polynomial after 3. All right, what things do I need to know about a polynomial? One thing is the end behavior. So the power term, that's the term with the greatest exponent. The power term determines the end behavior. So in this case, we only do have one term. I'm looking at, is it positive or negative in front? In this case, it's positive. And does it have an even or odd exponent? And so if it's positive with an even exponent, both ends go up. And how do I write that mathematically? So we're going to say, as x approaches infinity, f at x approaches infinity. As x approaches negative infinity, f at x approaches positive infinity. So we need to understand the right end is infinity, the left end is negative infinity. So instead of saying the right end goes up, we're saying x approaches infinity means right. The function goes to infinity, that means it goes up. So to the right, infinity, up infinity. To the left, negative infinity, down, negative infinity. So in this case, the right end goes up and the left end goes up. Here, it's negative with an even exponent. And so what would that tell me again about the end behavior? Both ends are going down. So the right end goes down and the left end goes down. If I look here at the end behavior, I notice it's positive and odd. So a positive with an odd exponent means the right end goes up, and we write down as x approaches infinity, the function approaches infinity. The left end goes down, so left means negative infinity, and down means negative infinity. Just getting comfortable with end behavior statements. The last one, negative with an odd exponent. So the end behavior again, the right end goes down. And the left end, which is negative infinity, goes up. So the right end goes down, the left end goes up. And we need to be comfortable how to write it. So we're going to practice that right now. So if I look at these examples, all I'm looking for is the power term, the term with the biggest exponents. That's negative x to the 4th. That already tells me it's negative and even. And if it's negative and even, what direction do the ends go? Negative and even, both ends go down. And this is how I write the statement. So that means we write down as x approaches infinity, the function goes down. As x approaches negative infinity, the function goes down. All right. So each one we're going to identify the power term and then where the ends go. So the power term is negative 2x to the 5th, which means it's negative with an odd exponent. You can go back a page and see where do the ends go if it's negative with an odd exponent. So that means the right end goes down So right, that's how you say right. Down, we say f of x goes to negative infinity. How do I say left? This is how I say left. And then how do I say down? Oh, up, I mean, because the right end goes down and the left end goes up. All right, let's try number 3. So identify the most powerful term. And then identify if that's positive and it has an even exponent. So if it's positive with an even exponent, as x approaches infinity, f of x, so the right end goes up, the left also goes up. Number 4, identify it. So the power term is 4x to the 7, which means it's positive with an odd exponent. So that means the right, there it is, goes up, and the left goes down. Now for number 5, because you can press pause, right, if you need to, the fraction has no effect of the end behavior. So the power term is 1/2 x to the 3. All I care about is positive with an odd exponent. That's what matters. So that means the right end goes up and the left end goes down. All right, last one like this. Identify the power term. So negative and even. That's all that matters. It's negative with an even exponent. So that means both ends go down. All right, if I look here at the graphs, it's easier. What's the end behavior of the graph? Just looking at a graph rather than an equation. Well, where's the right end going? So we write that down. And then there's a second part here. So we know the right end goes down, and we know the left end goes up. And then the next thing is, what do we know about the power term? So then we work backwards and go, I see it. If the right end is down and the left end is up, that matches if it's negative with an odd exponent. Yay? Okay, try number 8. Where are the ends going? Then we write it down. The right is going up. The left is also going up. Now, if both ends go up, what does that mean about the power term? So that means the power term must be positive with an even exponent. So that's how we describe it. All right, next part of the lesson, turning points. So when a graph has a turning point where it turns, if it has a high turning point, we call that a relative maximum. And if it has a low turning point, we call that a relative minimum. So if that turning point is higher where it turns, again, the full word, relative maximum. And if it's a lower one down here, we call it a relative minimum. Again, you can press pause if you need to. Both together, if you were asked for the extremum, fun word, those are the extremes of the graph, E-X-T-R-E-M-U-M. They're asking for both, the max and the min. All right, do you know how to use Desmos to find these things? So I'm going to go to Desmos. I have it right here ready to go. So I'm going to switch over. Oh, try it again. And I'm going to type in. So if you want to go to Desmos so you can watch how I do it. So let me type it in, right? F of x equals x cubed plus 5x squared. Subtract 8x, subtract 1. So I can see this graph, and I can press the minus sign to shrink it a bit, so that, and then I can drag the graph so I can see the turning point. Now in Desmos, you can click on where the graph turns. So that upper point is called the maximum. So where it says relative maximum in your book, that's -4 and -4 and 47. So if I switch over here, you can see I wrote -4 and 47. If I'm looking for the minimum, that's down here. I'm just going to round it, 0.7 and -3.8. So that gives me that. Now the next part talks about increasing and decreasing. When a graph increases, it rises. See from left to right, like if it's like a roller coaster, this one's going to the top of the roller coaster. That's rising. We call that increasing. So when I notice the beginning part increases, then at what x value does it stop increasing? And does it go, and now the roller coaster is going downhill. So that point where it changes, that peak of the roller coaster, is really important to understand the intervals of increase and decrease. So the first part of the graph, in the beginning part of the graph, we call negative infinity up to -4 is increasing. Then the next part of the graph, from here all the way here, when the roller coaster is going down to the bottom of the roller coaster, it goes all the way to 0.7. So it goes from -4 to 0.7, it's going down, and then after 0.7 to the end of the graph, it's going up again. So the beginning and the end are negative infinity, and then in the middle all are turning points. You got to practice that, right? All right, turn the page. So we're going to practice that right now with Desmos. And I'm probably going to go quicker than you like, so you're going to have to press pause when that happens. So I'm going to go to Desmos, and I'm going to type in, and I'm going to say out loud, and then I'll show my book after I'm done talking out loud about it. So first, we're going to type in the function. Sure, I typed it in right. Then we're going to look at that, and we're going to take this graph and fill in. So first of all, to classify it means what's the degree? What's the greatest exponent? Because it's 2, we classify this as quadratic. So I'm going to write it in, and then I'll show you after I'm writing. I'm not worried about the domain and range, so I'm just going to leave that for now. The minimum, what's that bottom point right here of the graph? And it's at -1, -6. Maximum, there's no high turning point. So sometimes they don't have that turning point. So we're going to write down none for maximum. Intervals. So the first part of the graph, the roller coaster is going down to the bottom. That's the first part of the graph. That's decreasing. So from negative infinity to -1, it decreases. And then after -1 to infinity, it then increases. And then the end behavior. Where's the right end and left end? So we're going to write down, as x approaches infinity, the function goes to infinity. The right end goes up. As x approaches negative infinity, the function also goes to infinity, which means the left end goes up, and that's what I want. Then we're going to graph it. So on my graph, I'm going to go to -1 and -6, 1 to the left and 6 down. I can also put the intercepts to, in this case, maybe like 1.5-ish, and the other one is -3.5-ish. And then graph it from there. So let me show you what my book looks like. And then you can press pause, and then you can make sure yours matches if you want. All right, number 2. While I'm here, the greatest exponent is 3. We call this a cubic. And the end behavior, it is negative and odd. So that means the right end goes down and the left end goes up. And then I'm going to find, I'm not going to worry about the domain and range, I'm going to find the turning points in intervals of increase and decrease. So I'm going to go back to Desmos. I'm going to type this in. So this is -2x cubed. Then it's 8x. So -2x cubed, 8x minus 1. Sure, I typed it in right. And then I'm looking at the turning point. So I start there. I'm going to round. So the minimum is at -1.2 and positive 1. And -7.2. The maximum is at 1.2 and 5.2. I'm going to put them on my graph right away. So it's basically -1 and -7. And then the other one is at 1 and 5. And then I'm just going to graph it. So for this one, I'm just worried about the turning points and the end behavior. So I know the right end goes down and the left end goes up, and I know my points where they turn. The first part of the graph decreases. So start at negative infinity, and then that x coordinate, which is negative 1.2. Then it increases. So from negative 1.2, it increases to positive 1.2. And then the last part of the graph, again, decreases. So from 1.2 to infinity. And I know it takes practice understanding the intervals. Let's practice again. Number 3. Press pause if you need to. I'm going to type that in. Well, first of all, let's see what I can do without Desmos. So what type is, so this we would say is a quartic. We're not going to worry about that. The end behavior, it's positive with an even exponent. So we're going to write down as x approaches infinity. So that means the right end goes up. As x goes to negative infinity, the left end goes down. No, both ends go up, sorry. And then we're going to use Desmos to help us out with this. So I'm going to bring back Desmos, and I'm going to type this in. So that's x to the 4th, subtract x cubed, subtract 4x squared, plus 1. And then if I need to zoom in just on the turning points, I will. So I can see where our bottom turning points are. I'm going to round. So I'm just going to call it negative 1, negative 1. The other one is like 2 and negative 7. Just going to round. 2 and negative 7 is fine. The maximum is right here, which is at 0, 1. And then I'm going to put that on my graph. So 0, 1, negative 1, negative 1, and 2, negative 7. That's going to go on my graph. So we'll move this graph over again. And then I know both ends go up. So I'm going to make this smooth and make sure both ends go up. I'm not worried about the intercepts right now. So the turning points and the end behavior. So the first part of the graph decreases. Start. So decreases. Negative infinity to negative 1. Then after negative 1 up to 0, it increases. And then after 0, it decreases to 2. And then the last part of the graph, from 2 on, it increases. So we're going to practice again. So number 4. So again, let's bring this over. So again, I'm going to type this in. So x to the 5th then it's minus 4x cubed. Then it's plus 2x. And then plus 3. Okay, so, and I'm going to zoom in where I have to so I can see my turning points. So I have 2, let's start there. The 2 low turning points are at negative 0.4 and 2.4. The other low one is at 1.5. and almost 0, right? Not quite. The maximums are at negative 1.5 and 6, and the other maximums at like half, right? Yeah, 0.4 and 3.5, 3.6. All right, so I'm going to go back here again, and I'm going to do some other things. So I classify, it's called a quintic. And the end behavior, positive and odd, and we can already see on the graph. The right end goes up and the left end goes down. Increasing, decreasing. Let's put these points on the graph. So negative 0.4 and 2.4. 1.5 and like almost 0. Negative 1.5 and 6. And then 0.4. Oh, that's 1.5 and 0. So 1.5. So it's like here. Sorry, this one's like at 3. Like that. And then we know the right end goes up. And the left end goes down. Smooth and continuous, curvy as best you can. the first part of the graph increases, so start at negative infinity, go up to negative 1.5, and then the next part of the graph goes down, so negative 1.5 to negative 0.4. Then it goes up, so negative 0.4 all the way to 0.4, and then the last part of the graph goes down again, 0.4 to 1.5. Now the last part of the graph is 1.5 to infinity. It increases. So 5 different intervals there. All right, let's try 2 more, and then the lesson's over. Type this in. I'm going to do the same thing. So I'm going to do it right here beside me, then I'll move it over. So type it in and I'll show you. You can do it too. We already know this is a cubic because of the degree. We also know the right end goes up and the left end goes down. All right, this is what it looks like. And again, I'm looking at, oh, these have beautiful turning points. So we have a maximum at 0, 2, and a minimum at 2 and negative 2. I'm going to put those on my graph. And I said we already know it's a cubic. I'm going to write it out. And we know the end behavior. The right end goes up and the left end goes down. And then intervals of increasing and decreasing. So connect this. So the first part of the graph is increasing, so we start at negative infinity up to 0. Then the next part of the graph from 0 to 2 goes down, and then the last part of the graph 2 to infinity goes up. All right, last one, number 6. This is classify it right away. This is called a quartic. And the end behavior, negative and even exponent, means the right end goes down, and the left end also goes down. I'm going to type this into Desmos and then I'm going to move it over. So we have negative x to the 4th, negative 2x cubed, plus x squared. And I'm going to move this over so you can see it. This one's a tricky one because there's like just a little, like this one's obvious, right? So that's a maximum. Super easy, obvious. I'll show you one in a second that isn't as obvious. So that's a maximum, negative 1.8 and 6.4. I'll put that in my graph right away. Now, the next one is not so obvious, so I'm going to zoom in so you really can see it. So right here is actually a minimum, and right here is a maximum. It's so subtle. So there's a minimum at 0, 2, and then there's a maximum at 0.3 and 2. So go figure. Then there's another turning point down here. This one's the, no, that's it. That's all the turning points. Okay, so I'm going to go back here. I'm going to put these on my graph. So I already put down 0.3 and 2, 0 and 4 is there, and then negative 1.8. I did that one already. Oh, 0.3 and 2. Which way? 0.3 and 2 is a maximum. There it is. So this one should actually be written here. 0.3 and 2 is a maximum. Oh, this minimum should say 0 and 2. And then this one's 0.3 and pretty well 2. I know, it's like silliness. So, it's just so subtle. And then both ends go down. So this part is increasing to begin with to negative 1.8. Then it decreases from negative 1.8 to 0. And then it increases from like 0 to 0.3, and then 0.3 after it goes down. Oops, positive infinity. It's when they're so small, it's a little bit silly to do it. Anyways, there's our lesson on polynomials. Mr. G Math over and out. Till next time.